What is polyvinyl chloride, which we find everywhere? Hey, engineering lovers! Have you ever stopped to think about how many objects around you right now depend on an incredibly versatile plastic? From the pipes hidden in the walls to the windows that seal your house, from the cables that bring electricity to the intravenous bag in a hospital. There's a good chance that many of these items are made of polyvinyl chloride. But what exactly is this material? How was it discovered? And why has it become so essential? Polyvinyl chloride stands for polyvinyl chloride. And it's a thermoplastic, which means it can be melted and reshaped multiple times when heated, returning to a solid state when cooled. Chemically, it is classified as a synthetic polymer. As we already know, a polymer is a large molecule formed by the repetition of thousands or millions of smaller units called monomers. The fundamental monomer of polyvinyl chloride is vinyl chloride, whose chemical formula is C2H3Cal. It is this chemical structure that gives polyvinyl chloride its basic properties, such as excellent chemical resistance, durability, rigidity, good electrical resistance, and remarkable versatility, allowing its final characteristics to be widely adjusted through the addition of various additives during production. But how did polyvinyl chloride originate? The history of polyvinyl chloride begins like many great discoveries, a 19th century laboratory accident. The French chemist Henri Victor Regnault was the first to observe the phenomenon around 1835. He noticed the formation of a white solid inside bottles containing vinyl chloride that had been exposed to sunlight. Regnault had synthesized vinyl chloride himself a few years earlier, but he did not investigate the nature of this unusual solid in depth. Almost 40 years later, in 1872, the German chemist Eugen Baumann independently rediscovered the same material by leaving bottles of vinyl chloride exposed to light. He also obtained an insoluble white powder. Polyvinyl chloride. Baumann studied its properties a little, but like Regnault, he did not see any practical applications, and the material remained a scientific curiosity for decades. Industrial viability only happened at the beginning of the 20th century, thanks to chemists who faced the challenge of processing this rigid and difficult-to-work polymer. And the key was to make it malleable. The German chemist Friedrich Heinrich August Klatt, working at the company Chemische Fabrik Griesheim Elektron, obtained the first patent for the production of polyvinyl chloride in 1913. His crucial contribution was to propose the use of plasticizing additives, such as tricresyl phosphate, to soften polyvinyl chloride. However, technical difficulties and the First World War delayed its commercial development. The decisive boost came in the 1920s, mainly in the United States. Waldo Simon, a chemist at the B.F. Goodrich Company, was searching for a synthetic adhesive around 1926. During experiments with polyvinyl chloride and solvents, he accidentally created a flexible and elastic mass. Simon immediately realized that he had discovered a practical method to plasticize polyvinyl chloride, turning it into a useful and versatile material. This accidental discovery enabled large-scale polyvinyl chloride production and use. But how is polyvinyl chloride produced? The manufacturing of polyvinyl chloride is a complex industrial chemical process, carried out on a large scale, and can be summarized in interconnected main steps. It all starts with obtaining the monomer vinyl chloride, and there are ways to obtain it. One of them involves the reaction of ethylene with chlorine to form dichloroethane. Once dichloroethane is formed, it is then decomposed by heating at high temperatures, usually above 500 degrees Celsius, producing vinyl chloride and hydrogen chloride. Another way, less common today, uses acetylene reacting directly with hydrogen chloride in the presence of a catalyst. Once purified liquid vinyl chloride is obtained, it is then subjected to polymerization. This is the crucial reaction, where the individual molecules of vinyl chloride bond with each other, forming the long chains of the polyvinyl chloride polymer. There are main industrial methods for this polymerization, with the most common one accounting for about 80% of global production being suspension polymerization. Then we have the emulsion polymerization method, and a third, less common method is bulk polymerization. The pure polyvinyl chloride resulting from this process, which comes in granules or powder, is rigid and brittle at room temperature. To turn them into the final products we know, it goes through a critical stage called compounding. In this phase, polyvinyl chloride is thoroughly mixed with a variety of essential additives, which modify its properties to meet the specific needs of each application. These additives include stabilizers, plasticizers, lubricants, impact modifiers, and even pigments. Finally, this homogeneous mixture, called compound, is transformed into the finished product through industrial processes such as extrusion, injection molding, calendaring, blow molding, or coating. If you remember that disaster that happened in Maceió with the sinking of the ground, that sinking happened due to the extraction of rock salt underground, which is basically sodium chloride. It's mainly used to produce dichloroethane, which, as we already know, is a raw material for the production of polyvinyl chloride. Where can we use polyvinyl chloride? The true measure of polyvinyl chloride's success lies in its impressive use in practically every sector of modern life. Its unique combination of properties makes it an irreplaceable material in countless applications. The dominant sector is, without a doubt, the construction industry, consuming about 70% of all polyvinyl chloride produced worldwide. Here, it is the preferred material for sanitary sewer pipes, stormwater pipes, drainage, and electrical conduits. Thanks to its corrosion resistance, lightweight, durability of over 50 years, and ease of installation. Polyvinyl chloride window and door profiles have revolutionized the market, offering exceptional thermal and acoustic insulation, very low maintenance, and water tightness. Coverings such as vinyl flooring, wallpaper, waterproofing membranes, and translucent tiles are also important applications in this sector. In the packaging field, rigid or semi-rigid polyvinyl chloride is crucial for the well-known blister packs, which protect and display pills, batteries, and small components. Bottles for mineral water, oils, cosmetics, and cleaning products, as well as shrink films for grouping bottles or packaging products, are also significant examples. The electrical and electronics sector relies heavily on flexible polyvinyl chloride to insulate and protect wires and electrical and telecommunications cables in homes, industries, and automobiles, taking advantage of its excellent dielectric resistance and durability. In health and medicine, highly purified and biocompatible flexible polyvinyl chloride plays a vital and life-saving role, because it is the standard material for blood and serum bags, catheters, drainage tubes, dialysis tubes, and parts of various medical devices, because of its transparency, flexibility, and safety. In addition to these, polyvinyl chloride is present in a number of consumer goods, such as shoe soles and components, toys, waterproof items, credit cards, and even for the production of synthetic leather for furniture, bags, and upholstery. But why is polyvinyl chloride still so relevant? Well, polyvinyl chloride has established its global position for very concrete reasons. It is an extremely durable material with a long lifespan, especially in construction applications like pipes and windows, where it can last for decades. In addition, it offers an excellent cost-benefit ratio, providing high performance at a competitive cost. Its unparalleled versatility allows for the creation of products with radically different properties, from rigid to ultra-flexible or transparent to opaque, simply by changing the additives in the composition. It also has good chemical resistance and fire resistance when properly formulated with flame retardants. Additionally, polyvinyl chloride is technically recyclable, and there are efforts in the industry to increase recycling rates, both mechanically through shredding and reprocessing, and chemically through decomposition to recover raw materials. If you enjoyed the video, subscribe, like, and turn on notifications. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and to be remembered in our videos. If you want to learn more about our recommended courses, scan the QR code or check the link in the video description to have access to various opportunities to develop several skills that will make a difference in your career. Did you know what polyvinyl chloride is? Have you ever used polyvinyl chloride in home construction? Share it in the comments, I want to know. Here on the side, there are 2 interesting video options that you need to watch to expand your knowledge and explore your curiosity. And if you want to support us, leave your like, subscribe to the channel, turn on the notification bell, and consider becoming a channel member. That's all, engineering fans. Big hugs, see you next video.